Welcome to Mathematics in the new video, Fibonacci numbers, trigonometric form. Yeah, our goal is we will show that we can write the Fibonacci numbers in these two forms. So minus I to the power n times 2 times square root 5 over 5 times the hyperbolic sign of n times natural log of I pi. And second form, yeah, it's similar. You can read it by yourself, where the log is the natural logarithm and I is the imaginary unit, so I squared is minus 1. And also we will answer the questions, what is the motivation to find such a relation? Before we start, I want to make some recalls and assumptions. So if you don't know about Fibonacci numbers, there are many videos and internet web pages where you can find these properties. So the initial values for the Fibonacci sequence is f0 is 0, f1 is 1, and we get the next Fibonacci number by the sum of the previous two. And there is a closed form expression for the Fibonacci numbers. It's called Binet's formula. We will not prove it here. Also, yeah, like I said, you can find proofs in many other sources. So a closed form for the Fibonacci numbers is phi to the power n minus phi to the power n over square root 5, where phi is the golden ratio 1 plus square root 5 over 2. Okay? Yeah, and I want to talk about the structure of the Fibonacci numbers, and this will lead us to get the idea to write the Fibonacci numbers with the hyperbolic functions or the trigonometric functions. And if we take a look at Binet's formula, we have a base to an exponent minus some base to an exponent over a number. So here base to some power minus base to some power over a number. And if we compare this to e to the x minus e to the minus x over 2, we see that this looks quite similar. Here is a minus. So they look quite similar. The exponents have different signs, and yeah, there is a constant in the denominator, and the bases are quite the same. They differ also by a sign, and this is not the case for the hyperbolic functions. Yeah, they have the same base, same exponent, but difference in the sign. So it's a question if we can force our expression to make use of the hyperbolic sign. So we want to get rid of this minus in some sense to make these bases the same. This is our task. Yeah, how can we do this? Our theorem is the trigonometric form of the Fibonacci numbers. We have seen this a couple of minutes before. Yeah, now we will prove this. And the first step is we start with Binet's formula, and we want to add something which we can use in a different way. And there is not much we can do, but here the minus sign, this is a minus 1, so we can try to write it as I squared. I squared is negative 1. So we have Fibonacci number is phi to the power n minus I squared phi quantity to the power negative n over square root 5. The next step is to extend the denominator and numerator with the fraction 2 times I to the power n over 2 times I to the power n, so nothing changed. And then we make a little bit of algebra, and I let you to check that this is here correct. We get 2 over square root 5 times I to the power n times the fraction in the numerator. We have I phi to the power n minus I phi to the negative n over 2, and now we have the same basis, and these form what we want for the hyperbolic sine. Okay, so like I said, take pen and paper and make sure you get this form. Now we use we can rationalize the denominator. Of course, we extend by square root 5 the numerator and denominator. So, and also we multiply numerator and denominator with I to the negative n. To get rid of the imaginary unit and the square root in the denominator. Then we get this expression, okay? And the next step is to write these powers in terms of exponentials. So we make use of an exponential of logarithm of x is x, and then we have the power rule for the logarithms, so these exponents come in front of the logarithms. Okay, and now we have the form for the hyperbolic sine, e to the power minus e to the negative power over 2, and this is exactly the definition of the hyperbolic sine. And now for the trigonometric form, we make use of the property that hyperbolic sine of a complex number is minus I times sine of I of this complex number. So we get at the final result this expression minus I to the n plus 1 times 2 square root 5 over 5 times the sine of in times logarithm of I phi. How beautiful is that? Before we end, I have two small tasks for you. There is a natural extensions for the Fibonacci numbers for negative indices, and show using the hyperbolic or the trigonometric form, so that we have f of minus n is minus 1 to the power n plus 1 of Fibonacci of n. And b, there is a very similar sequence, maybe the little brother of the Fibonacci sequence. These are the Lucas numbers, denoted with a capital N, capital L, and the initial values are 2 and 1, and the recursion is the same, so the next Lucas numbers you get with the sum of the two previous ones. And find a similar trigonometric and hyperbolic expression for the Lucas numbers. Have fun, enjoy, and bye bye.